Hello student, welcome back to lecture series on Z transform. Already I have uploaded plenty of the videos. If you are interested to see these guys, go and check here in my I button. So you will get the complete playlist for Z transform, inverse Z transform, Fourier sine, cosine and unit first. All playlist you will get it in my channel, okay? Or you can check in my description box here also. You will get entire playlist in my description box. In my today's video guys, I'm gonna explain to you all solution of a differential equation with a constant coefficient using Z transform. Already in my last lecture I explained to you all difference of equation, some standard form in our lecture, okay? Yes. So using these three steps we are going to solve some of the example in our today's lecture, okay? Yes. So let me write one of the example here for our today's lecture. I'm gonna explain first of all the example and then we go for the solution. So here I written one example guys, okay, f of k plus 2, 3 into f of k plus 1 plus 2 into f of 1 which is equal to 0, okay. So we want the Z transform for this sequence, okay. Now what we do, we are going to apply these three steps over here for this the Z transform, okay. For this difference equation, okay, we are going to apply these three steps for this difference equation with initial conditions are also given, okay. First of all, what we need, we want the Z transform. Okay, we want the Z transform for this entire sequence. We want the Z transform for this entire sequence. Okay, yes. Then later on we are going to substitute initial condition. These are the initial condition. F of 0 which is equal to 0. Okay, this one is a f of 0. Okay, the f of 0 which is equal to 0 and f of 1 which is equal to 1. These are the initial condition we are going to replace in our Z transform, and at the end what we do, we go for the inverse Z transform. Okay, so we go for finding its inverse Z transform, and our target here, what is our claim, we have to find out the sequence f of k. Okay, this one is the solution for our difference equation. Okay, we want the solution here now, so we are working for the solution of difference equation. So in our previous lecture, I explained to you all some substitution values. Okay, what are these substitution value? Whenever we have Z transform of f of k, okay, so Z transform of f of k, we write it as the f of z. Okay, whenever we have Z transform of f of k, we write f of z here. Okay, yes, these are the value we have to replace here, okay, in our given difference equation. Okay, yes, Z transform of f of k is f of z. We have f of k here, we want the f of k plus 1, so Z transform of f of k plus 1. Okay, we write, okay, Z transform of f of k plus 1, we write Z transform of f of z minus z into minus z into f of 0. Okay, okay, these are the values guys. Okay, these are we needed here for substitution. Okay, so f of k written here as f of z, f of k plus 1. Okay, f of k plus 1, we write z f of z minus z and f of 0. Okay, so we want f of k plus 2. Okay, we write z transform f of k plus 2. Okay, Z transform of f of k plus 2 can be written as, okay, Z transform f of k plus 2 can be written as z square f of z. Okay, z square f of z minus z square f of 0. Okay, z square f of z minus z square f of 0 minus z into f of 1. Okay, minus z into f of 1. Okay, this one is the value for Z transform of f of k plus 2. Okay, so we are going to replace these values in our difference equation. But as we observe our difference equation, it seems like that we have here only f of k plus 2, f of k plus 1, f of k, but we want z now, so we don't have z here. So what we do, we apply z transform to both sides, apply z transform this side as well as apply z transform for this side. Okay, so that means by linearity property you can write z transform of k plus 2 plus 3 times z transform of k plus 1 plus 2 times z transform of f of k, which is equal to z transform of 0. Okay, I'm going to apply directly linearity property for Z transform of entire function. Okay, yes. So apply Z transform. Okay, apply Z transform. Where you have to apply to the our given difference equation. Okay, so Z transform of f of k plus 2. Okay, so when you take Z transform, always remember guys, write down in the form of sequence. Okay, we need a sequence to apply Z transform. Okay, yes, plus 3 outside here, Z transform of k plus 1, Z transform of k plus 1. Okay, 3 times plus 2 times Z transform of k. Okay, which is equal to Z transform of 0. Okay, yes. So actually see that this is the our Z transform I applied over here. Okay, yes, always remember that guys, Z transform of 0 gives us the value 0. Okay, it is like a differentiation integration. We know that na, differentiation of 0 0, integration of 0 it is also 0. Similar like Z transform of 0 is a 0. Okay, always remember this one. Okay, so replace this value Z transform of k plus 2. What we have here? Z square f of Z. This one entire value replace here, then this entire value replace here, and this value replace here. Okay, yes. So I'm going to write this one value here. Okay, Z square f of Z, Z square, okay, f of Z, okay, minus Z square f of 0, okay, minus Z f of 1. Okay, I replace this entire value instead of it here. Okay, plus 3 times under bracket. Okay, Z transform f of k plus 1, Z transform of Z minus Z transform of f of 0. Okay, Z transform of f of Z minus Z transform of f of 0. Okay, bracket complete. Okay, 3 times Z transform of f of k plus 1. I am writing it here. Okay, so it is coming here from here. Okay, plus 2 times Z transform of k. Z transform of k is f of Z only. Okay, f of Z. Okay, which is equal to Z transform of 0. It is always 0. Okay, always remember that Z transform of 0 is 0. Okay, yes. So go for solving the steps here. Those who are the similar can try to cancel them. Those are not possible to cancel, keep them as it is. Okay, yes. Now see that f of 0 is given value 0. Okay, so f of 0 is a 0. That means this term gives us value 0. This term gives us value 0. Okay, so what we have here, f of 0 is a 0. Now we have to put initial condition over here in this difference equation. Okay, so f of 0 is a 0. That means this term goes to 0, this term goes to 0. Okay, yes. So f of 1 is a 1. Okay, now see that f of 1 is 1. This one gives us the value 1. This one, is there f of 1? No. Okay, so we write this one as 1. Okay, so Z square f of Z. Okay, we cannot do anything. F of Z, we don't have any condition here on f of Z. So Z square f of Z keep as it is. Okay, this one goes to 0. So keep this for a few minutes. Okay, yes. So f of 1 is a 1 over here. Okay, f of 1 is a 1 here. So we left here with the value only Z. Okay, yes. So plus 3 times Z f of Z. Okay, plus 3 times Z f of Z. I'm writing this one here. I'm going to write this one later on. Okay, plus 2 times f of Z. Okay, now see that Z square f of Z here. Okay, 3 times f of Z here, plus 2 times f of Z here. Okay, and remaining minus Z, write it here, which is equal to 0. Okay, I hope you all have understood how I have written, because after replacement f of 0 0, f of 1 is 1. Okay, after replacement of f of 0 0 and f of 1 is 1, you will get this step. Okay, this entire step. Yes, Z square f of Z plus 3Z f of Z plus 2 times f of Z minus Z is equal to 0. Okay, yes. So what you do, take minus Z to the other side, we get the positive Z, and take f of Z throughout common from here. So I'm going to write f of Z outside over here. Okay, under bracket z square plus 3z, okay, under bracket z square plus 3z plus 2, which is equal to z. Now see that, let me explain what I have done here, okay. So I taken f of z out here, okay, multiplied by under bracket z square plus 3z plus 2, okay. That z I taken it outside here, okay, another side. So how I am going to write f of z? F of z can be written as z divided by z square plus 3z plus 2. Okay, now see that I got the f of z right now, z upon z square plus 3z plus 2, okay. Yes, so this one is some sort of a simplified form of z transform, okay. It is way easier, guys. Now we have to apply over here z transform, okay. So I'm going to apply z transform over here, but before that it seems like that a denominator is some sort of a square, okay, some term of square, okay. So we know that z square plus 3z plus 2 are having roots 2 and 1, okay, roots 2 and 1. So we can write z square plus 3z plus 2, okay, z square plus 3z plus 2 as z square plus 2z plus z, okay. We want the two number, their multiplication 1, their addition 3z, okay. So z plus 2z, which is a 3z, and 2 into 1, which is a 2, okay. Yes, so take z common from here, we left here z plus 1, okay. Again z 2 common here, plus 2, z plus 1, okay. Yes, so we can see that z plus 1 and z plus 2, we have two factors over here, replace here, okay. So I'm going to write this one as z upon z plus 1, z plus 2, okay. This one is a f of z I written over here, okay. F of z I written over here using this one, okay. Now see that z upon z plus 1, z plus 2, it seems like that it's using partial fraction method, okay. Yes, it is using as a partial fraction method. So let's apply partial fraction method then, okay. By using partial fraction method, we are going to solve this z transform, okay. Yes, so f of z is equal to z upon z plus 1, z plus 2, okay. So z upon z plus 1, z plus 2 using partial fraction can be written as a upon z plus 1 plus b upon z plus 2, okay. I'm going to write this one in this form, okay, a upon z plus 1 plus b upon z plus 2, okay. So go for the cross multiplication, a into z plus 2, okay, this into this, plus b into z plus 1, okay, bracket completely divided by this into this, z plus 1, z plus 2, okay. Yes, this one I written over here, this is the just cross multiplication, guys, okay, and it equal to z upon z plus 1, z plus 2, okay. Now see that this one is similar to this one, you can cancel it here, and we go for solving partial fraction for the value of a and b. Here z which is equal to a into z plus 2 plus b into z plus 1, okay. Let me take to the next page. So I written here next step, z which is equal to a into z plus 2 plus b into z plus 1, okay. Yes, so for finding the value of a and b, we have to make whether a0 or b0, okay. If you want to make a0, consider the value for z where a goes to 0, or if you want to make b0, consider the value for z for getting b0, okay. Yes, so I'm going to consider the value for z here for to make a0, okay. So if I put z, if z which is equal to minus 2, okay, if I replace z is a minus 2 over here, okay, z is a minus 2, then we write minus 2 which is equal to a into minus 2 plus 2 plus b into minus 2 plus 1, okay. This one is the value, okay. Now see that minus 2 plus 2, it goes to 0, so minus 2 which is equal to a into 0 plus b into 2 minus 1, okay, it is a minus 1, okay. So we write b which is equal to 2 only, okay. This is the actual value for b, which is a 2, okay. So that negative, take it to the other side, it gives us the value 2, okay. So I got the b here. Similarly, find out the value for a, okay. So for finding the value of a, make the b 0, okay. So for making b 0, we need z as a minus 1, okay. Yes, put if z which is equal to -1. If z which is equal to -1, then we write -1 which is equal to a into -1 plus 2 plus b into -1 plus 1. Okay, yes. This is just replacement of value as a z as a -1 over here. Okay, so -1 plus 1, it gives us the 0. So -1 which is equal to a into 2 minus 1, 1. Okay, a into 1 plus b into 0. Okay, so a, we get the value -1 over here. Okay, so I got the value for a is a -1 and b is here as the 2. Okay, so replace a and b in our required f of z. What we have f of z? F of z which is equal to z upon z plus 1 z minus z plus 1 z plus 2. Okay, yes, this one is our required f of z we found in our example, and we have written as a upon z plus 1 plus b upon z plus 2. Okay, so I written a upon z plus 1 plus b upon z plus 2. Okay, this one we written f of z. Okay, yes. Now what we do? We replace a and b over here. A is -1, b is a 2. Okay, so we replace a is a -1 upon z plus 1 plus b is a 2 upon z plus 2. Okay, so this one is the actual value for f of z. F of z, I got the -1 upon z plus 1 and plus 2 upon z plus 2 over here. Okay, yes. So let's go for the applying inverse z transform. Okay, so z inverse of f of z. So we have third step. What is the third step we have here? Find out the inverse z transform. Find out the inverse z transform for finding the f of k. Okay, yes. So this one is the f of z. Okay, that means it is the z transform of f of k. Okay, this is the z transform of f of k, means f of z. So we want the f of k only. That means you have to take the inverse z transform. Okay, so z inverse of f of z. Okay, z inverse of f of z. Okay, that is the value for f of k. Okay, z inverse of f of z is f of k. So z inverse of z upon z plus 2. Z upon z plus 2. Under curly braces, z inverse of, this one is the curly braces, guys. Okay, yes, z inverse of z upon z plus 2. Okay, no, this is not the z, guys. B is value for b is a 2. Okay, this one is a 2 upon z plus 2. Okay, 2 upon z plus 2 over here. Okay, and then later on what we have here, I written this z inverse over here. Okay, minus, take it outside, minus outside, z inverse of, under curly braces, 1 upon z plus 1, 1 upon z plus 1 over here. Okay, this one is a complete. Okay, inverse z transform. I written this way over here. Okay, so we have to find out the inverse z transform for these two sequences. Okay, I already explained in my last lecture. Okay, so I'm going to just replace the value to take it outside. Okay, to outside, z inverse of 1 upon z plus a. Okay, 1 upon z plus a, whenever k greater than 0, we write its the value as a minus a raised to. What is the value for a? It is a 2 here. Okay, yes, so minus a minus 2, we write minus 2. Okay, minus 2 raised to k minus 1. K minus 1. Okay, this is the z inverse inverse z transform of z with 1 upon z plus 2. 2, it is outside here, guys. Okay, so 1 upon z plus a, having inverse z transform minus a raised to k minus 1. Okay, yes, so that means a is equal to 2, so minus 2 raised to k minus 1 minus z transform of z inverse transform 1 upon z plus a. Okay, so we write it's a z inverse transform minus 1 raised to minus a raised to k minus 1. Okay, minus 1 raised to k minus 1. Okay, and k greater equal 0. Okay, now see that this is the required z inverse of f of z as a f of k. Okay, this one is a required our f of k. Okay, this one is the given relation. Okay, this one is the relation between our given difference equation. Okay, this one is the relation between given difference equation. I hope you all have understood, guys. It is way easier to solve this equation. Okay, not that difficult. Okay, I want you all to solve one of the example similar like this one. Okay, okay, this one is the example. I hope you all have understood, nothing difficult. And even after if you found anything difficult, na guys, let me know in my comment section. I will come up with a similar videos. Okay, so let me write one of the example, that one for your homework. Okay, here take this example for your homework. Okay, obtain sequence f of k. So you have to similarly find out the value for f of k, and I written here difference equation 12 times f of k plus 2 minus 7 times f of k plus 1. Okay, minus 7 times f of k plus 1 is this, guys. Okay, minus 7 times f of k plus 1 plus f of k, which is equal to 0, and the condition on k greater equal 0. Initial conditions given, f of 0 which is equal to 0 and f of 1 which is equal to 3. Okay, take this example for your homework. Tell me the answer in my comment section, guys. Okay, and if you have anything difficulty into it or any doubt, let me know, guys. Okay, yes, so I have one more example for you all. Okay, I'm gonna explain to you all that one now. Okay, we keep this example for our next lecture. Okay, because other side it is non-zero there. Okay, so maybe it will be quite confusing to you all. So as we have right hand side present, we solve this example in our next lecture. Okay, till that we stop here. Okay, I hope you all have understood, guys, my today's lecture. Even after, if you found anything difficult, confusing or challenging, let me know in my comment section, guys. We'll come up with the similar videos. And one more thing, that if you do have some more examples like this or challenging difficult question, comment me in comment section, guys. I will come up with their solution too. So thank you everyone, thank you for my today's lecture.